if you're ready, we're going to do the anatomy of the squid. Woohoo. Hold on to your mantle cavity. Okay, so here you go. I'm speaking, I've actually made an incision here. So I'm showing you, I'm just going to kind of give you the tour, okay? So this is an unnatural incision, so just pretend like that's not there. And so this right here, these are the fins, okay? This is actually, this tip right here, that is actually the dorsal surface. Okay, which means the ventral surface is going to be down here, okay, around these arms and tentacles. We're looking at the siphon right here, and that tells you that I've started you posterior. So when you want to flip it around anterior, let's do it. Anterior. Fin. Dorsal. Anterior surface. Ventral surface. And then look, now that we're more anterior, we do have an eye and an eye, bilateral eyes. And the eyes are really just like our eyes, although they're not homologous, but they have lenses, they have a cornea, kind of a retina-like structure. All right, now at the, right, if we look in, like right on, full-on ventral surface, there's the mouth at the base of these arms. So we have 8 arms. Okay, 4 on each side. We can count them. Okay, let's get everything kind of lined up again. Here we go. Okay, so we can count 8 arms, 4 on each side, and then 2 of these longer tentacles. And these tentacles are raptorial. What that actually means is that they can be sort of ejected and grab stuff really quickly. Like think, for example, a chameleon's tongue. Exactly the same kind of idea, right? Raptorial, and it's even based like on a largely hydrostatic skeleton. Okay, which meaning that it's muscular. All right, now, so the deal is that is like the orientation of these body axes is so counterintuitive, it is ridiculous. So like by definition, right, the mouth is generally at the anterior end of the animal, right? And in an animal with bilateral symmetry, right, kind of the long skinny axis is usually anterior posterior, but here it's not. Here, anterior posterior is between my thumb and middle finger. And dorsal and ventral in a bilaterally symmetrical animal is usually like our belly to back. But here, it's between my left hand and my right hand. And so maybe we can understand the symmetry of this animal functionally. But in fact, this animal, right, moves by jetting whoosh, that way. Dorsal side first. So it's like, you can memorize the axes, but it would be kind of cool to understand them, right? I mean, I think. Besides that, if I don't understand them, I can't remember them anyhow. So let's do this, okay? To try to figure out how these axes work, what we need to do is we need to see how they develop from the generalized molluscan body plan. And there's a couple of drawings down here that'll help us do that. So I'm going to put this down, and we're going to look at these drawings. Next take.